So we're going to continue where we left off, more with the basic derivative rules. And number 7 is the rule for the derivative of the natural log function. And we're just going to memorize this derivative for now. All of these will be something that we'll be able to come up with eventually when we learn more calculus. But for right now, that's what you want to know, that the derivative of the natural log function is 1 over x. And we just memorize it. So again, if you have some note cards, I would add that one to my note cards of ones to memorize. Okay, so we're going to see that some of our rules of logarithms are going to come up in here. And if you felt a little bit shaky on them, we don't really go into really hard logarithms. So this should come back to you. Okay, so we're going to start out. Let me just rewrite this problem over here. Now, there's a rule of logarithms that if you have a log or a natural log of a number that has an exponent, then you can move that exponent to the front. Okay, so that is a rule of logs. It has nothing to do with calculus. It has nothing to do with the derivatives. Okay, I can just move that right out front. Okay, so when I want to find the derivative of this, so I'm going to leave the constant alone. And again, there's a thing called the product rule that I need to show you that will make sense on why I leave that there, why I don't go, well, didn't you earlier say that the derivative of a constant is 0? That is correct, but this is 3 times the natural log of x. So I'm going to leave that 3, and I'm just going to leave that there right now. So I'm going to leave the constant. And again, we're going to prove why that stays that way. Okay, so f prime of x is 3 over x. Okay, lots of examples of these coming up. Okay, so number 8 is the derivative of y equals e to the x. And this is a very interesting one. It's the only function whose derivative is the same as the original function. No other function that does this. Okay, so this is going to be another one that we memorize. Maybe I'll box these here so you can see what you're memorizing. Okay, so let's just look at a bunch of examples where I'm going to put these two together. Okay, so let's say that the derivatives say find d dx. And remember, that's just another way for saying find the derivative. Okay, so y prime, f of x, f prime, d dx, same thing. Okay, so let's say we have that g of x equals the natural log of x squared times e to the x. Okay, so now we're going to use another rule of logs. That could be a long time since you've done it, but the rules of logs, remember that logs are exponents, and that when we multiply exponents, we add, or we multiply these, we would add the exponents. So we had a rule of logs that said Well, this is the same exact thing as the natural log of x squared plus the natural log of e to the x. Okay, so again, that's just a rule of logs, that if they were multiplied, you add them. Also notice that I have natural log written twice. Okay, all right, so now our rule from up there says, all right, if you you can move that 2 to the front. And here I know that these are inverses of each other, so that's just x. Remember that natural log of e is 1. That just cancels out. Okay, so this is still g of x. We haven't found the derivative yet. So now I'm going to find the derivative. Okay, so I'm going to leave the constant, and I know the derivative of natural log of x is 1 over x. So 2 times 1 over x will be 2 over x, and the derivative of x is 1. There it is. Okay. Do some more. We'll get comfortable with these. Say y equals the natural log of 2e to the x over 3x. Okay, so first thing that I'm going to start with is I'm going to do my rule of logs. So the rule of logs says that if you divide these, you can you subtract. So this is the same thing as the natural log of 2e to the x minus the natural log of 3x. Okay, now I'm going to still do rules of logs. So if I had these two, okay, these are multiplied together. So this is the natural log of 2 plus the natural log of e to the x. Okay, I'm going to subtract, and I'm going to keep this, I'm going to put brackets, I could put parentheses. This is the natural log of 3 plus the natural log of x. Okay, so again, I have not found the derivative yet. All I'm doing is changing the form of this. Okay, let's see what else I can do. Well, this is the natural log of 2. Now, we saw this already and we said it equals x. I want you to think about, what if I just moved the x in front? Because that's just another way for you to think about it. Okay, the natural log of 3 plus the natural log of x. Okay, so all of these are rules of logs, and you'll see that when we do logs, we keep using these same rules over and over again, that when you multiply, you add, when you divide, you subtract. So they'll come back to you. Okay, so let's look at this, natural log of 2, because now I'm going to find the derivative. Well, that's just a constant. Okay, so I know sometimes it looks weird, and you're like, wait, is that a number? Am I supposed to have a rule? So I'm going to do natural log of 2 just to show you. That's just a number. Okay, so we know that this is a constant. Maybe I won't put that there. Okay, we know that that cancels out, and this just equals x. We know that this is a constant. And we know the derivative of the natural log of x is 1 over x. Okay, so let me get my, so this is one you might have to think about. I'm looking to see if I have some white out around here. I do. Okay, so I want to get rid of this. Okay, so the derivative of a constant is 0. Remember, that cancels out. This is x. The derivative of x is 1. The derivative of a constant is 0. And the derivative of the natural log of x is 1 over x. So our derivative of this thing, oops, I see another mistake. This should be a minus, right? Because I needed to distribute that minus right there. So this should be a minus. Okay, so y prime is equal to 1 minus 1 over x. Alrighty. Okay, I'm trying to think if we can fit 2 more on this tape. I think we can. Okay. Tape, whatever we're doing, video. Okay, so there. Okay, so another example. Let's find the derivative of f of x equals the natural log of 4x cubed e to the x. Okay, so I'm going to start with my my rules of logs. So I got a bunch of stuff multiplied together here. So I'm going to start by saying, well, this is the natural log of 4x cubed plus the natural log of e to the x. Okay, well this I can split apart. This is the natural log of 4 plus the natural log of x cubed. I'm going to move the x to the front. Okay. This is again natural log of 4. I'm going to move the 3 to the front. And I know the natural log of e is 1. So that just gives me that. Okay, let's find our derivative. This is a constant. Derivative of a constant, that's 0. This is 1 over x. We leave the 3. The derivative of x is 1. And there it is. Okay, let's see. Let's get one more in here. Let's get that g of x is pi e to the x minus 1 over the cube root of x squared. That doesn't look very pretty. So let me rewrite it. Pi e to the x minus, I'm just going to say this is x to the negative 2/3. Okay, so let's go ahead and find our derivative. Okay, so g prime of x. Okay, now remember that pi is a constant. Remember our brain likes to think that sometimes it's a derivative, and we just said we're going to leave that constant there. And the derivative of e to the x is e to the x. Remember, that's the only weird one. This will become a plus 2/3 because I'm going to bring that down. And then 2/3 minus 1 would be 2/3 or negative 2/3 minus 3/3, which would be negative 5/3. Okay, so g prime of x is pi e to the x plus 2 over 3x to the 5/3. Okay, and then just a little note just so that you see, so when we're working with these, and I'll just let you copy it right here. Okay, keep that in mind. All right, that's it.